Hi everyone, we are Team Tech Brigade. We are presenting our web project 3 Conway's Game of Life. Next slide. We are team of three. I am Prasanna and I have worked on all parts HTML, CSS, JS, PHP, and it's the same for everyone in our team. We have divided our task and continued with the project.
Hi, my name is Dattu Reddy Mathur. So, as she told, we have divided our work and equally helped each other in all of the technologies. And one of our teammate is Divya. She's also helped with PHP and HTML.
Next slide. So coming to problem statement, Conway's Game of Life is a well-known example of a cellular automation, which is a mathematical model that simulates a system of cells, each of which can be in one of several states. The game consists of a grid of cells that can either be alive or dead and evolves over time based on specific rules. So the problem to be solved in the context of Conway's Game of Life is to develop a software program. So in our case, it's using HTML, CSS, JavaScript, and PHP that can accurately simulate the evolution of the grid over time based on the initial configuration of the cells and the rules governing their behavior. The program should be capable of displaying the grid at each time step and allow users to modify the initial configuration of the cells and the rules that govern their behavior. Moreover, our project should be able to handle large grid sizes and long simulation times without compromising computational efficiency. And to add to this, we had different rules and regulations for this game. So we had to follow all those in building this. Next slide, please. So the general requirements for our software program that simulates Conway's Game of Life are, for suppose our inputs are the size of grid, the initial configuration of cells, which can be specified by the user or generated randomly, the rules that govern the evolution of cells, such as number of live neighbors that are required for a cell to remain alive. So this is one of the condition, or the number of live neighbors that will cause a cell to die. So this is another condition. Outputs, the state of the grid at each step of the simulation displayed graphically, with cells colored according to whether they are alive or dead. Statistics about the state of the grid, such as number of live cells, the number of dead cells, and the overall density of the grid. So for suppose we have given as population generation. Next slide, please. So let's go through the overview of solutions. So defining the grid, create a table in HTML to represent the grid, which each cell having an initial state of either alive or dead. So we use CSS to style the table and cells. Coming to rules, use Java. We have used JavaScript to define the rules for the evaluation of the grid based on the number of neighboring cells that are alive or dead based on condition. For example, a cell that is currently alive may continue to live if it has 2 or 3 live neighbors, but will die if it has fewer than 2 or more than 3 live neighbors. Coming to updating the grid, we use JavaScript to iterate over each cell in the grid and update its state based on the rules defined in the previous step. This will produce a new grid that represents the state of the simulation at the next time step. So coming to displaying the grid again, use of JavaScript to update the table in HTML. We have implemented buttons to allow users to interact with simulations such as start, clear the board, likewise I mentioned pausing, resuming, and handling error and unexpected input. So implemented error handling and input validation in JavaScript to handle unexpected inputs and errors gracefully and provide clear feedback to the user. Could go to next slide. So, considering the key design features, so one such is user interface. So, our web page looks user friendly and visually appealing interface that allows user to easily interact with the simulation. And the next one is performance. Our design solution is fast and efficient with the ability to handle large grid sizes and long simulation times. So, reusability, our code could break. Down into smaller and reusable parts that can easily be interacted with other parts. For suppose if I want to improve anything in future and add any other features, our solution handles errors and unexpected inputs, as I mentioned previously. So we implemented input validation through JavaScript. Next slide, please. So this is how our UI looks like. So there is generation, population, game board, buttons, and other title and login register. Next slide. So this is the UML diagram. So we have chosen activity diagrams. So where just firstly user just enters the page and he can log in and register. Then he can go to start the game. So you can then there is already game present, so he can play on the same or click on new board. Then he can use the slider move to increase the speed of the generation, and there is a button called step for every cell, and we could check population generation in the game, and in the end we can clear the board. And the final exit is we could log out or exit the browser. Next slide. So we have used Trello to track the task, which is Kanban methodology. It helps us a lot to divide the task and iterate them. So creating the design template or ad styling, working on login page. So we all worked on different things. So to interact with that and keep track, like how is it in doing thing or it's already done. So for that interaction and to even reiterate, it was very helpful for us. So we just put some little code snippets here. So we have one such is we have made use of first state in React JS, which allows us to manage changing the data in our application. So you can see that clear board, handle new board, handling toggle cell status. Yeah. So this slide is about some of the CSS styling we use. So we have used CSS animations to animate transitions like the main title of the game in the home page. So that is animation pulse is infinite. So we have used that keyframes pulse. Coming to testing, first part, functional testing was performed to ensure that the user interface functioned as intended. So the list goes with the input validation, error handling, and ability to use our buttons that maybe start, clear the board, pass, and reset. Next comes regression testing. As changes were made to the code, regression testing was performed to ensure that existing feature continues to work as intended. So there were a lot of changes we were making. So this helped catch bugs that may have been introduced as a result of the changes. So it was continuous iteration process till the output came as we expected. So bugs fixed or not fixed. So all bugs were recorded and prioritized based on the severity, and all critical and major bugs we fixed in the process. So it's now bug free application to be used. So yeah, there are also few problems faced. So one such one is we have faced difficulty connecting React JS and PHP But suppose we have a login page, so that is easy generally to redirect to .php, but we had difficulty connecting that to React.js. And second one is very simple one, but game was difficult to understand as it is a 0-player game. We generally have 1 or 2 players, so it is easy to understand, estimate, and write the code for such. But it's just a simulation game, so that was difficult to understand for us. The next slide. So thank you. This is our project, and let us go to our demo and see how it works.
Let me take you to the demo now. Um, so as you can see the screen, so this is how whenever you land on the game page, it is how it looks like. The title you can see reanimated with the help of CSS, and also we have choose an animated background which makes more looks like an actual gaming website. And you can also see the login or register button. When the user first lands, it will ask to either log in if you already have an account, or register for the new one to play the game. And the grid here displays in the middle of the page, and you can also see the current generation of the cells, and also it also displays the current population, which means the total number of cells that are alive at this moment. So we have also as part of the requirement, this board is also the dynamic one, like based on the user configuration, that the number of rows and column counts can be changed, and the board size can be increased or decreased, whatever the user likes. And if you scroll down a little, you can see a few more controls here. There's a slider which will actually helps to either increase or decrease the movement of the cells which are moving here and there. And also you can see start button. With this is the actual button to start the game, so the cells start moving. And this is a step to for each of the cell. And clear board clears everything, like it makes the board clean, and new board will load the new board every time whenever the user want to stop in the middle or start the new game. So now let's click on start. As you can see, the cells start moving, and you can see the count is updating as well. The current generation, and the current population, it's like increasing and decreasing. So this displays the current alive cells at this moment, and you can just we'll just test this slider. So when you try to increase the speed, you can see the cells are moving very fast. Similarly, when you move it right side, so we decrease the speed. And also you can click on stop, which halts the population and generation. The clear board clears everything, and if you want a new board and start again, you just click on new board, which will load it again cells with some population, which will changes after the game starts. This is how actually our home page looks like, this actual game page. And if the user wants to register, just register. We have a login page, and if they are new, they can register here. If they are already having an account, they can log in from here. Yeah, I think that's it. Like, Prasanna, you want to add anything, or we're good?
Yeah, good, Dattu, and thanks for your time. So this
Yeah,
is how our project looks like. Thank you.
thank you. Bye.